understanding though, you could use the tablet, because I know that one involves asking the questions.
Yeah.
Right. So,
But
okay.
Or you could use you could put down all the slang and have them translated, translate this slang into precise language, and this is your activity for the next 10 minutes.
Well, one of the things that English teachers do a really good job of when using Excel, teachers already identify, when you look at the lesson, you're like, okay, these are some words that are going to trip kids up.
Yeah.
Like, this is a heavy word, has multiple syllables, it could have a different meaning. So let's go ahead and get that one out the way. So
Right.
Here's the word we're going to be talking about today. I think we did it in, I think I observed Mr. Kreitline's class a couple of weeks ago, and he was doing it. But you still hear kids say the one on the bottom, or things like that.
Yeah.
So students translate mathematical terms into practice. Precise words and meanings.
So that was what Mr. Hart was saying.
That would be a nice activity there.
Right, so if they make sure that even if they might understand that, we could tell them like, hey, it's not just the number on top, it's the numerator. You know what I mean?
Right.
And who guides that according to core action 3E? The teacher connects and develops students in formal language. So as Mr. Hart was saying with the entry point, if I keep saying flip it, Mr. Hart, I just flipped it. And you say, no, Otis, what's the word that we are supposed to use? Remember we talked about using the inverse, whatever it is. And then forcing me to use that language, correcting my language. So that's moving it from informal to formal.
Right. What would that be, just like enforcing it though? Like just a word like to make sure we stay on, I won't just say stay on task, but we make sure we reinforce it, because we don't want them to be on that Monday and Tuesday. We want them to continue that as we're going forward. So
you could do it in your bell work or something. Not a translation thing, but you could have, find the slope of a line perpendicular to this line, and then say, explain how you got that. And then they would have to say, well, I took the negative reciprocal of the slope of the original, and so they'd have to use the term, so that's like reinforcing. After you talk about it, then you can throw stuff like that in your bell work and just spend a minute or two on it after the students are done.
So possibly
just to reinforce it.
Creative exercises.
But have them write it out. So explain your answer.
Okay, so writing it out.
But it doesn't always have to be that involved. It could be real-time feedback to correct.
Sure. Yeah, when you're just communicating with a student or with the class, and if you're asking questions and somebody uses the wrong term, then you give the reinforcement right then and feedback to the student that you remember we did talk about this. What was that word? If you need me to tell you, I'll tell you. But I want to hear you using it. That kind of thing.
Let's take
intentional about consistently reinforcing.
A couple of times I played dumb when talking about quadratics. I'm like, oh, what's the name for this graph that we draw here with this quadratic? I'm like, it's problem, Mr. K.
What about some non-examples? What's wrong? You quit?
No, I didn't. I was thinking. I was like, I don't have any non-examples. We don't have any.
Well, let's think about some non-examples. So, what would be some poor practices? So students use increasingly precise mathematical language and ideas. What would be the opposite of that? What would I show? Go ahead, Ms. Crichton.
One that I used to be guilty of that I'm trying a lot better at is over-explaining things, not letting the students have an opportunity to use the terminology themselves.
You cleaning up what they say.
Yep. So if a student says something wrong, or when a student asks a question, I used to always be like, oh, this is the answer because I know it. But right now I've been redirecting to a lot more and you can use that for the language and stuff. Like a student says, oh, the number on top, I'm like, so-and-so, what's the name for the thing that's up on top? Just redirect it so students can have that opportunity. But not giving them the time would be the non-example.
Yeah, not giving the students time to figure out what,
Okay, he says air time.
Not monitoring air time
when students
are challenged to
just merely pointing it out every time and not having the students.
Mr. Saffold let me know during my
express to Teachers not monitoring airtime when students are challenged, what? Like when students are challenged to solve or understand themselves or.
How about just challenged with the language of a problem? Because that covers all of it, you know?
Yep.
Because, words are words, and, they're different for different kinds of problems, but you've got to understand them
Okay.
all.
I'm gonna ask our math content lead to give us some, maybe one example and non-example for teacher practice, and then one example and non-example for student practice. You can see what we already have, Miss Terry.
No, but I'm saying, I'm saying,
On the spot.
Oh, Lord.
Okay, so,
Furniture gets moved.
I know one example that I see of students just using their own informal languages when they're solving equations. And they're always like, subtract 7.
Right.
Instead of saying, I subtracted 7 from both sides.
Yeah.
Or I'm using the subtraction property of equality. So that is a move that teachers can jump in and say, make sure that we're using it right.
So when you say the subtraction method of
Subtraction
equality,
property of equality.
property of equality, or side, angle, side, angle. So what do you call those? Are those conjectures? Is that a conjecture?
No, that's a property.
It's a
Okay.
property of that equal sign.
It's
If
of
you
the
have an
equal
equal
sign.
sign, it's
Well, I'm
not
saying, but
property.
is there a way to classify all of those up under one umbrella? So
It's like a
Postulates and
man.
theorems,
postulates and theorems.
Yes.
Except for
these
the
are-
properties are properties.
They're
Okay.
properties.
There's
But-
3 things there.
So
So the purpose of doing it is really like for Algebra 1 and so else also for Algebra 2, they have a standard in which the kids have to actually justify why they solved the problem.
Right.
And there's no justification that says subtract 7.
No, right.
And so when they're looking at the list and they give them a student's show a student's work, and it puts a justification there next to each step, they have to select the justification that's incorrect, supply justification, or find the misstep that the student took, and what would be the correct step. So me saying subtract 7 from both sides is not a property, but the property is called subtraction property of
You
equality.
can't use that for
And so
justification.
students should be using it. That's their precise language, and that's their mathematical idea.
okay.
So,
All right, so it looks like we have a lot of examples. What are some non-examples that we see when we observe teacher practice, or what are some non-examples of this? I'm gonna include one that I'm gonna do what Mr. Kreitline was telling me. It's called rounding up. When you tell the kid, okay, so what you're saying is, and you clean it up. So it's called a roundup. And they really didn't say it, and they be like, yeah, that's it. That's what I was trying to say.
but what
Or they're
you want
fast.
to see is when they're increasing. So the next time it comes around, the student won't have to round up. They're using the language now. So every time I come in, they shouldn't continue to give me like what their informal
Right.
idea is. They should be using the precise language because they're going to be tested on the precise language. I know another example. A non-example is like even when we're introducing the properties and statements and postulates and theorems, for us to paraphrase them.
Yep.
Let's not paraphrase them. Let's say them exactly the way they are. Let's be precise about what they are, and let's make sure that our students understand what the meaning is. But when we paraphrase, we're paraphrasing on top of something that they already don't understand, and we can't shortcut their misunderstanding.
So paraphrasing would be a non-example for teachers. Teachers paraphrasing.
Right, teachers paraphrasing.
I think if you introduce the precise and proper language to help the students understand it, you might paraphrase, but you're still going to have to require them to use the proper language. Obviously you got to explain what it means,
Yeah.
one way or the other.
Well, that's the reason
So
why I
you
was
could
saying
say-
use that school-wide practice of using the Excel. If it's
Right.
if it's a concept, theorem, postulate, or whatever, you like, okay, this is important. It is an anchor of the task that we have to do. I'm gonna take 3 minutes and we're gonna go over this word.
I
Because
want
it's
to
right,
add one
right.
more thing in there too, especially so Algebra 1 and Algebra 2, they have AREA, A1, which asks the students to be able to explain their reasoning, justify solutions. In geometry, you have GCO A1, which is to know the precise definition.
Okay.
So when we're introducing vocabulary, even if we're using it, this would be a good time to use the Excel, because your textbooks give you a certain definition, but what is the technical definition for that word? Because students are going to be tested on, do they know the technical, scientific, precise definition for the word. I'll give you an example like circles. So the definition that they keep testing the kids over, do they know about circles is, they define a circle as a locus of points that are equidistant from a center point. But that's not how we describe a circle in class. So just tying it into the technical plus whatever the textbook says, and this would be a good chance for us to use Excel.
Okay.